Hello students, welcome to the Schooling Hub. Today we will do 5th chapter of Algebra unit, that is Indices. Before starting, please like and share our videos and subscribe to our channel. We will start with our 7th question. We have a part, that is if x raised to power 20 under root 4 under root 5 is equal to x raised to power p, find p. We have to find the value of this p. First of all, what equation we have? X raised to power 20 under root 4 under root 5, that is equal to x raised to power p. Under root 5 can also be written in the form of power. So we will write x raised to power 20 under root 4 bracket power. Under root 5 will be written in the form of power as 1 by 5. That is equal to x raised to power p. Similarly, under root 4 can also be written in the form of power. That is x raised to power 20 raised to power 1 by 4. And we have whole power, that is 1 by 5 is equal to x raised to power p. 1 by 4 and 1 by 5 will be multiplied. X raised to power 20 powers will be 1 by 4 multiplied by 1 by 5 is equal to x raised to power p. This will be x raised to power 20 1 by 20, that is equal to x raised to power p. Now these powers will also be multiplied. X raised to power 20 multiply 1 by 20, that is equal to x raised to power p. 20 and 20 will be cancelled. Here what we have? X raised to power 1, that is equal to x raised to power p. Now we know when we have similar coefficients, the powers are equal. Hence value of p is 1. We have B part of 7th question. If a raised to power minus 1, b raised to power 2 divided by a raised to power 2, b raised to power minus 4 whole power 7 divided by a 3, b raised to power minus 5 divided by a raised to power minus 2, b raised to power 3 whole power minus 5 is equal to a raised to power p multiplied by b raised to power q. We have to find the value of p and q. First of all, here we can see that these both terms are in division. But when we will multiply this term with this, then this parts will get changed. Means now if this power is in positive, then its sign will change to negative. If this power is in negative, sign will change to positive. Now we will write this as a raised to power minus 1, b raised to power 2. This is in division, but we will multiply this. A raised to power will be minus 2 and b raised to power will be plus 4 because the power sign get changed. Whole power 7 divided by. Similarly, we will multiply both these terms. A raised to power 3, b raised to power minus 5 multiplied by a raised to power plus 2, b raised to power minus 3 whole power we have minus 5, that is equal to a raised to power b multiplied by b raised to power q. Now these terms are in multiply and coefficients are similar. That means powers will get added. Minus 1 minus 2 multiplied by b raised to power 2 plus 4. Whole power we have 7 divided by. Here two same coefficients, powers will be added. A raised to power 3 plus 2 multiply by b raised to power minus 5 minus 3 whole power minus 5, that is equal to a raised to power p multiply by b raised to power q. This will be a raised to power minus 3 into b raised to power 6 whole power 7 divided by a raised to power 5 multiply b raised to power minus 8 whole power minus 5, that is equal to a raised to power b multiply b raised to power q. Now we will multiply these terms with these powers. a raised to power 7 into 3, 21 minus 21, multiply by 7 into 6, 42, b raised to power 42, divide by, similarly we will multiply this term with these, a raised to power will be minus 25 into b raised to power 8 5s are 40, and minus sign multiplied by minus sign is positive, hence b raised to power positive 40, that is equal to a raised to power p, b raised to power q. Now both these terms are in division, hence similar coefficients parts will be subtracted. A raised to power minus 21 minus minus 25 multiply by b raised to power 42 minus 40, that is equal to a raised to power p, b raised to power q. Here a raised to power minus 21 plus 25, this will become, hence power will be 4, b raised to power 42 minus 40, b raised to power 2, that is equal to a raised to power p into b raised to power q. Now coefficients are similar, this means power must be equal, hence p is equal to 4. Here two coefficients are similar, hence powers must be equal, hence q is equal to 2. We have C part of 7th question. If 4 raised to power n plus 1 multiplied by 2 raised to power n minus 8 raised to power n divided by 2 raised to power 3n is equal to 3 divided by 8, prove that n plus 1 is equal to m. We need to prove that n plus 1 is equal to m. First of all, we have to solve this equation. We have 4. We know 4 can be written as 2 raised to power 2 whole power, we have n plus 1 multiplied by 2 raised to power n minus 8 can be written as 2 raised to power 3 whole power, we have n, divide by, we have 2 raised to power 3m, that is equal to 3 divided by 8 can again be written as 2 raised to power 3. Now we will solve this. 2 raised to power, powers will get multiplied, 2 raised to power 2n plus 2 multiply by 2 raised to power n minus, these parts will also be multiplied, 2 raised to power 3n divide by 2 raised to power 3m, that is equal to 3 divided by 2 raised to power 3. Now we will multiply these both. This will be 2. We know coefficients are similar, 2, 2. Hence these parts will get added. 2 raised to power 2n plus 2 plus n minus, we have this term 2 raised to power 3n, This term is in division. When we will take this term to the upper side to multiply, then this positive power will become negative. Hence this will be 2 raised to power minus 3m, that is equal to 3. Similarly, when we will take this term to the upper side, power will become negative, 2 raised to power minus 3. 2n plus n will become 3n, 2 raised to power 3n plus 2 minus 2 raised to power 3n multiplied by 2 raised to power 3 minus 3m, that is equal to 3 multiplied by 2 raised to power minus 3. Now from these both terms, 2 raised to power 3n, 2 raised to power 3n will be common, 2 raised to power 3n is common. So here it is left 2 raised to power 2. Because 2 raised to power 3n we have taken as common, minus here this is 1 multiplied by 2 raised to power 3m minus 3m, 3 multiplied by 2 raised to power minus 3. Now this we have 2 raised to power 3n to the square we have 4 minus 1 multiplied by minus 2 raised to power minus 3m, 3 multiplied by 2 raised to power minus 3. Now we will 4 minus 1 will be written as 3 multiplied by 2 raised to power minus 3m, that is equal to 3 multiplied by 2 raised to power minus 3. Now this 3 and this 3 will be cancelled. Now what is left with us? 2 raised to power 3n multiplied by 2 raised to power minus 3m, that is equal to 2 raised to power minus 3. Now these terms are in multiplied and coefficients are similar. 2, hence parts will be added, that is equal to 2 raised to power minus 3. Now the coefficients are similar, that means parts must be equal. 3n minus 3m is equal to minus 3. Here 3 will be taken as common, n minus m, that is equal to minus 3. N minus m will be equal to this 3 will be divided on the other side. Hence n minus m is equal to minus 1. N is equal to minus 1 plus m. N plus 1 is equal to m. What we need to prove is n plus 1 is equal to m, and that we have proved. We have D part. If x plus y power minus 1 multiplied by x raised to power minus 1 plus y raised to power minus 1 is equal to x raised to power p y raised to power q, then prove that p plus q plus 2 is equal to 0. First we will solve this and we will take out the values of p and q. X plus y raised to power minus 1. This can be written as 1 divided by x plus y, because the power is minus 1. When this will be in division, power will become positive. Multiplied by x raised to power minus 1 can be written as 1 plus x, divided by similarly y, 1 upon y, that is equal to x raised to power p y raised to power q. Here we have 1 upon x plus y multiplied by, here LCM will be x multiplied by y plus x, that is equal to x raised to power p y raised to power q. Now we have x plus y, hence this will be cancelled. So we have 1 upon xy, that is equal to x raised to power p y raised to power q. 1 upon xy can be written as x raised to power minus 1 y raised to power minus 1, because this is in division, that is equal to x raised to power p y raised to power q. Coefficient x is similar, hence value of p will be minus 1. Coefficient y is similar, hence value of q will also be minus 1. Now we have this equation, that is p plus q plus 2 is equal to 0. We need to prove this. We have value of p minus 1, value of q minus 1. Minus 1 plus value of q minus 1 plus 2 is equal to 0. Minus 1 plus 2 is equal to 0. Minus 1 minus 2 plus 2 is equal to 0. Minus 2 plus 2 is 0, that is equal to 0. Hence here left hand side is equal to right hand side. This means if right hand side and left hand side are equal, hence we have proved it. We have next part. If 2 raised to power x multiplied by 5 raised to power y multiplied by 7 raised to power z is equal to 98 multiplied by 10 raised to power 3. We have to find x plus y plus z. First of all, we will take this right hand side term. We have 98 multiplied by 10 raised to power 3. We will write the factors of 98. We have 2 multiplied by 7, 14. 14 multiplied by 7, 98. Multiply. Similarly, we will write the factors of 10. We have 2 multiplied by 5. The cube. 2 multiplied by 7 multiplied by 7 multiplied by 2 raised to power 3 multiplied by 5 raised to power 3. Now we have 2 raised to power 3, 2 raised to power 1. These are in multiply, hence 2 raised to power will be 4 multiplied by, we have 5 raised to power 3 multiplied by 7. 7 raised to power 1, 7 raised to power 1. Hence 7 raised to power 2. Now this we have right hand side. Left hand side we have 2 raised to power x, 5 raised to power y, 7 raised to power z. Now we will compare left hand side and right hand side. Z, that is equal to 2 raised to power 4, 5 raised to power 3 into 7 raised to power 2. Now we have similar coefficient 2. Hence power of x will be 4. Similarly, we have similar coefficient 5. Hence power of y will be 3. Similarly, we have 7. Hence power of z will be 2. Now we have value of x, y and z. What we need to find is x plus y plus z. Hence x plus y plus z will be equal to 4 plus 3 plus 2, and that is equal to 9. We have 8th question, prove. First part is under root x power minus 1 into y multiplied by under root y power minus 1 z multiplied by under root z power minus 1 x is equal to y. We need to prove that this is equal to 1. Under root. We know under root can also be written in the form of power. X raised to power minus 1, y raised to power 1 by 2 into, similarly we will write all the under roots in the form of power. Now we will multiply these parts within the bracket. X raised to power minus 1 by 2 into y raised to power 1 by 2 multiply by y raised to power minus 1 by 2, z raised to power 1 by 2, z raised to power minus 1 by 2, x raised to power 1 by 2. Now this term has negative power. This means when we will write this term in the form of division, then the power will become positive. Hence we will write y raised to power 1 by 2 divided by x raised to power 1 by 2 multiply by z raised to power 1 by 2. We have negative power of y. Hence we will write y 1 by 2. Here we have negative power of z divided by z raised to power 1 by 2. Now we can see that x raised to power 1 by 2, x raised to power 1 by 2 is getting cancelled. Y raised to power 1 by 2, y raised to power 1 by 2 is cancelled. Z and z raised to power 1 by 2 is cancelled. Hence this is equal to 1. And that is what we have to prove, that this is equal to 1. We have next part of 8th question. X raised to power m by x raised to power n whole power l multiplied x raised to power n by x raised to power l whole power m multiplied x raised to power l by x raised to power m whole power n is equal to 1. We need to prove this. First of all, we will write these terms in the multiplication form. X raised to power m into x raised to power minus n, because we are writing this in multiplication. X raised to power n, x raised to power minus l whole power m, x raised to power l, x raised to power minus m whole power n is equal to 1. We will multiply these parts within the bracket. X raised to power ml, x raised to power minus nl, x raised to power nm, x raised to power minus lm x raised to power ln x raised to power minus mn. Now we know that coefficient x is similar in all terms. Hence we will take coefficient x and powers will get added, plus nm minus lm plus ln minus mn. Now if we see positive ml, negative ml cancelled, minus nl plus nl cancelled, plus nm minus mn cancelled. Hence we have x raised to power 0 and we have red loss, that is x raised to power 0 is equal to 1. We have C part, prove AB under root x raised to power a by x raised to power b into x raised to power b x raised to power c under root bc into x raised to power c by x raised to power a under root ca is equal to 1. First of all, we will write all these under roots in the form of powers. X raised to power a divided by x raised to power b. Under root ab can be written as 1 upon ab into x raised to power b divided by x raised to power c. Power will be 1 by bc into x raised to power c divided by x raised to power a. Power is 1 by ca, that is equal to 1. Now we will multiply these terms within x raised to power a, multiply by 1 upon ab, divide by x raised to power b, multiply 1 upon ab, whole bracket, multiplied by x raised to power b, multiply 1 upon bc, divide by x raised to power c, multiplied by 1 upon bc, multiplied by x raised to power c, multiply 1 upon ca, divided by x raised to power a, multiply 1 upon ca. Now a cancel, b cancelled, b cancelled, c cancelled, c cancelled, a cancelled. Now we have x raised to power 1 upon b divided by x raised to power 1 upon a, x raised to power 1 upon c divided by x raised to power 1 upon b, x raised to power 1 by a by x raised to power 1 by c. Now we can see x raised to power 1 by c, x raised to power 1 by c cancelled, x raised to power 1 by b, x raised to power 1 by b cancelled, x raised to power 1 by x raised to power 1 by cancelled. Hence this is equal to 1. Hence proved. So students, today we have completed some questions of Indices chapter. If you have any doubt, then let us know your doubt in the comment section, or you can DM us your doubt on our Instagram page. Our Instagram account link will be provided in the description. Please students, do like and share our videos, and please subscribe to our channel. Thank you.